Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Sailesh Patel, and we are going to continue our chapter belt drive, and in this lecture we will solve some other examples from the belt drive. Okay, let's start. So you can see here the shaft rotating at a 200 rpm drives another shaft at a 300 rpm. Okay, so it transmits the 6 kilowatt through the belt. Okay, belt is 100 mm wide, so width and thickness of belt is given. The distance between two shafts means x is given here. The smaller pulley is a 0.5 meter diameter. Calculate the stress. So first of all we have to, in this example we will find the stress here, and for that open belt drive mu is given 0.3. Okay, so let's start the example of belt drive and we will find this stress. Okay, so we will find this stress. So first of all write down the given data. This is the rpm n1, this is the n2. Okay, power, it transmit the power 6 kilowatt through a belt, and width is given. Okay, width of belt is equal to, and this is the t thickness. Distance between two shafts means x is also given. Smaller pulley 0.5 meter. So first of all this diameter of smaller pulley is given, and here the 2 rpm of is given. So we have given this is the n1 and this is the n2. So which diameter this will be, d1 or d2? You know that larger the rpm, smaller the diameter. So this 0.5d we will take as a n2, because larger diameter is equal to, larger rpm is equal to n2. So we will take this smaller pulley as a d2, and larger pulley will be d1. Okay, first of all we want to find the stress here, and stress in only one equation there is a stress. It is equal to tension is equal to stress into B into thickness T. So B is given, thickness is given, but we have to find maximum stress and maximum tension, and maximum tension is equal to T1 tight side, because centrifugal is not given, so we will not consider the TC here. Only tight side T1 will be maximum tension. So we will find the tight side, and after that we will find the stress. Okay, let's start. So for that, first of all we need the D1 here, diameter of larger pulley, and for that you know that the formula is equal to N2 upon N1 is equal to D1 upon D2. So we have the data like RPM, N2 is equal to 300 divided by N1 200 is equal to D1 divided by D2 is equal to 0.5. So you will find the answer here, D1 is equal to 0.75. Okay, 0.75 meter. So this is your answer here. Okay, so you can write here D1 is equal to, you have find it 0.75 meter. After that we need the velocity. Okay, so we have find it the D1, and our purpose in our this example we will find the tight side T1. And how you can find this tight side? So how many formulas you have in which the tight side is there? So first formula is this, T1 upon T2 e raised to mu theta. Okay, there is a T1 inside that. And second is a power is equal to T1 minus T2 into velocity. These two formulas are there in which there is a T1. Okay, so we need both, we will use both formula. This T1 upon T2 e raised to mu theta, and power is equal to T1 minus T2 into velocity, because power is already given, 6 kilowatt. Okay, so using these two formula we will find equation number 1, and from this equation number 2, and T1 and T2 Both are unknown right now, but after using these two formula, we will find the T1 and T2. So for that, okay, first of all, we need this theta. We have to find this theta. So first of all, we will find this theta here. So we will put this in value and we will find the equation number 1. And for that, we will find the velocity here, because velocity is not given. So we will find the velocity and then we will find the equation number 2 here. Okay, let's start. We are going to find the theta first, and for theta we need the alpha here, and alpha is equal to sine inverse r1 minus r2 divided by x. Okay, so sine inverse r1 is already, we know that r1 means we have finded the diameter d1 and d2, so we have to divide this diameter by 2, so we will find the radius. Okay, so if you put all this value here, you will find this r1 minus r2 divided by x is equal to 0.03125, and sine inverse of that is equal to alpha, you will find the 1.8 degree. Okay, so alpha is equal to 1.8 degree. So you will find the theta here. Theta is equal to pi minus 2 alpha, and you will find the 176.4. But this is in degree. You have to convert into radian. Pi divided by 180. Okay, pi divide. So you will find the theta here, pi divided by 180 into 176.4. So your theta is equal to 3.08 radian here. And this theta we will use in T1 upon T2 e raised to mu theta. So you will find here, if you put the mu is equal to 0.3 is given, so you will put here 0.3, and theta is equal to 0.03, so you will put 3.08. so you will find here T1 divided by T2 is equal to 2.52. Okay, and second equation we have the power base equation we have. So this formula, this will be our equation number 1. Okay, now we are going to second. So we have the second formula here. So for that we need power is equal to T1 minus T2 into velocity. First of all, we need this velocity. Let's find velocity is equal to pi d1 n1 upon 60. So you will find the pi d1 n1 upon 60. So your answer will be 7.8 meter per second. Okay, you will put this value here, and for power, check this. Power is equal to, here 10 raised to 3 is there. Okay, 6 into 10 raised to 3. Okay, so you will put this value here, 6 into 10 raised to 3 is into T1 minus T2 multiply by velocity 7.8 meter per second. So you will find here T1 minus T2 is equal to the in a form of formula 764. So this will be your equation number 2. This will be your equation number 2. This will be your equation number 2 here, equation number 2. And using this T1 minus T2 and T1 upon T2. So you can put here this formula in this case, and you will find T1 and T2 both. Using equation number 1 and 2, you will find T1 is equal to 1267 Newton and T2 is equal to 503 Newton. So these two data we will find, and it is very essential because if we want the stress, we need this tight side here. This tight side will be used for finding the stress. Okay, so let's check. I am going to find the stress here right now. Okay, So we know that maximum tension is equal to stress into B into T. So we need to find this stress. Stress is equal to T divided by B into T. T divided by B into thickness T. So T we already find it that maximum tension is equal to tight side. Okay, because centrifugal tension is not given. If centrifugal tension is given, this will be we should add this centrifugal tension in this, but right now this centrifugal tension is not given, so we will use only here T1 tight side as a maximum tension. So it will 1267 divided by B is equal to 100 and T is equal to 10. So it will be 100 multiplied by 10. So you will find this answer. Stress is equal to 1.267 Newton per mm square. Because this is in Newton and this both are in mm, so unit will be Newton per mm square. Okay, if you convert this in a meter, this both value, your answer will be Newton per meter square. Okay. Okay. Now we are going to understand the V build. There is only change in this shape. Up to this point we have seen the flat build and pulley is like this. So there is a friction between this belt and pulley, but this friction is not sufficient. So in this V build there is a slotted pulley is used, and there is a two surfaces are there where friction is there between belt and this pulley. Okay, so that's how we can get the more friction and very less slip in this V build drive. But V belt is used only for shorter distance, not for longer distance between two pulley. For longer distance flat belt is used, but shorter distance it is very compact, so it transmits the more power also, but reliability of this V belt is less than the flat belt. Okay, so you can see here, first of all, two surfaces are there, between them belt and the pulley there is a friction. So the total in flat belt, we have seen this in flat belt, what is on surface of pulley, the total force and this reaction in this direction. But due to here two surfaces are there, so on pulley there is a two reaction, which is, you can see this in figure. The reaction means we have to take the component of this two reaction R1 to compare this total reaction on a vertical direction. Okay, so check this. So this vertical reaction is equal to this sine component of R1 plus sine component of this R1. Okay, so this R is equal to, you can check here the angle, this total angle is 2 beta. So if you put the line here like this, and there is a 90 angle, this will be 90 minus beta. So cos component, you can say, so this half angle will be beta here, so it will be 90 minus beta, and cos component of R1 means R1 cos 90 minus beta, it will become the sine beta. Same to same for this R1, and it will become 2 R1 sine beta. Okay, so our R1, this reaction is equal to R divided by 2 sine beta. Okay, so as you know, the in contact ratio upon T1 upon T2 for the flat belt, T1 upon T2 for flat belt, you know that it is e raised to mu theta. But in case of V belt, you will find mu r cosec beta here, and so you will find here for the V belt, T1 upon T2 is equal to e raised to mu theta cosec beta. So that is the change in a flat belt and in a V belt here. Okay, so this is the V belt, this is a flat T1 upon T2 e raised to mu theta and T1 upon T2 e raised to mu theta and cosec beta. So this is the very small change. We have to remember that this is the small change. If the V belt is used, but remember that this is the beta is given. If there is a given, the slot is angle is given 30 degree. This angle, total angle is given 30 degree. But this total angle, we have said total angle is equal to 2 beta. So in formula we have to put this is as a 15, half of that total angle. If this angle is given as a 20 degree, so 20 degree is equal to 2 beta, and in this formula mu theta cosec beta is here, so we have to divide this total angle by 2. So it is, if it is 20, we will use here 10. Okay, we will use here as a 10 as a beta. Okay, so remember that.